Okay, sorry about that. So for those watching from home, we've been solving equations with variables on both sides. And so to do that, we've been trying to eliminate the variable term from one side using addition subtraction. So it's probably good for us to review. Here we added 2x to both sides. 15 equals negative 5x. We're able to solve it. So you move the variable term from one side to the other side, just like you move constant terms from one side to the other side using addition subtraction. Okay, so here's the problems we've done. Sometimes when you do a problem, we don't get a nice integer answer. Equations don't always give you integer answers. You can get fraction decimal answers. You can write your answer as a fraction or decimal, by the way, however you want to write it. It's up to you. Move the variable to the side that makes it positive. The reason, by the way, that I wrote that on here isn't that you can't solve it if it's negative. It's just that when you're working with inequalities, it makes it easier. Do you guys remember working with inequalities last year? Maybe? Inequalities are solved in the same way that equations are solved. Meaning to solve this inequality, I would need to divide both sides by -2. But when I get my answer of +8, there's a special step that you have to do when you divide by -2. Does anyone remember what it is? What special step do you have to do when you're solving an inequality and you just multiply, divide by a negative? Really? You don't remember? Lizzie? That's right. So when I divide by -2, yes, I get +8, but it's going to be y is now less than +8. Now, the fact that 90% of you forgot that step is exactly why, if you have the choice, you should always make your variable positive. Because equations, it doesn't matter. What are you going to do? Flip the equal sign? You would, wouldn't you? What do you get when you flip an equal sign? An equal sign. But when you flip an inequality sign, it changes. And so if you have the choice to have a positive variable term or a negative variable term, if you can make the variable term be positive, when we get to inequalities next chapter, you won't have to flip it. That's why it matters when you're doing inequalities. Not so much when you're doing equations, but it's a good habit to get into. We just saw that problems can have no solution. If the variable term cancels and the resulting statement is false, then there is no solution. That catches us up. We're ready for this one now. Example H. If there's a number in front of the parentheses, Chloe, what should I do with it? That's right. Chloe, what's 4 times 2x? And Chloe, what's 4 times -3? Uh-oh, is right. We're going to subtract 8x to move it from the left side to the right side, or vice versa. It doesn't really matter, because when I put -8x down on both sides, it cancels out. I'm left with this. Now, is that statement true? Yes. Okay, so here's what that means. We're not going to put no solution. If the variable in an equation is eliminated and the resulting statement is true, okay, meaning this works versus the last one that did not work. So I put no, I should probably just put an X through it, whatever. This time we are going to say that there are infinitely many solutions. I don't know if I spelled that right, so please check that.
Okay.
INX.
I was actually going to tell you could abbreviate it as just mini solution, like mini sol, like that. Infinitely. The E's in the wrong spot should be switched to the L. Oh, it was weird.
That looks better.
Okay, thank you. I just had to be recording for that part. Okay. Now, I say that, but not every equation is going to have infinitely many or no solutions. A lot of them, a lot of times, will just have one solution. If an equation has one solution, that means it's completely normal, like all the ones you did in today's Kahoot. They all had one answer, right? Normally, we have one solution. What I'm telling you is that It's okay to have one solution, but it's also okay to have no solution or infinitely many. So there's actually three choices. It's either going to have one solution, infinitely many solutions, or no solution at all. So let's look at this next one. Combine your like terms. What does 2c and negative 3c get you? Negative 1c. If you're thinking 5c, you need to see that that 3 is negative. Plus 4. And then over on this side, what does negative 9 and positive 5 get you? Xander?
Negative 4.
Negative 4. Okay, so time out for 1 second. Let's go investigate real quick the last two problems we did and see if we can find any common themes between them. Did you notice that in the first question, it was negative 4x and negative 4x? You had the same number of x's on both sides. That's why they canceled out. Over here, it didn't look like we did at first, but when we distributed, we found out we had the same number of y's on each side. X's, sorry, I can't read my writing. X's on each side. So 8x and 8x, they cancel out. So that being said, this one's going to cancel out because we have negative c and positive c, right? No. Are negative c and positive c the exact same number? No, it's only when it's positive c and positive c, or negative and negative c. So here it looks like it's going to cancel out. This one's misleading. It's not actually going to, and I'll prove it to you. If I add c to both sides, it doesn't actually cancel out both of them. It only cancels out one of them and makes it 2c. Where do I have two equal signs?
I don't know. I never did that.
That look better? Okay. Now, if my variable term is going to be on the right side, because I want to make it positive, then I've got to move my constant term to the other side. Eight equals 2c. You see this is not one of those problems where you get all solutions or no solutions. That's only going to happen if you have the same exact number of coefficient variable on each side. So whatever that coefficient is, if it's the same on both sides, that's when you raise the red flag. Something goes off in your brain and says, okay, something's not right here. It's either going to be all solutions or no solutions. I investigate a little bit further. I find out if it's true, all solutions. If it's false, no solutions. I'm going to divide by 2 on both sides. What's 8 divided by 2? 4. Okay. Example J. Oliver, what do you get when you distribute a negative 1/2 to a positive 6x? Okay. And what about negative 1/2 of negative 4? Perfect. Right about now, your red flag should be going up. Something's wrong. You have the same x coefficient on both sides, don't you? So they are going to cancel out. And when they cancel out, what are you left with? What are you left with, Brady? And is that true or false? So do I write no solution or many solutions? That's right. Technically, it's infinitely many. It's not just like many more than you can count. It's like infinitely many more than you could ever, or any computer could ever count. No, you couldn't. Is this one going to give you, are the variable terms going to cancel out in this one? No? Okay. No, I heard no first. What's 6 times 5?
Yes.
What's 6 times 5? 30. What's 6 times negative 2b? Negative 12b. What's negative 4 times 3b? Oh, wait a second. I forgot I have to distribute first before I tell whether it's going to be no solutions or all solutions, right? And then what's negative 4 times positive 1? Negative 4. So then when I add 12b to both sides to move one to the other side, it doesn't actually matter because they both cancel out. And I'm left with this. By the way, make sure you go ahead and take it all the way to here. Okay, on your quizzes, on your homework too, but on your quizzes, if you just like leave me this and then say it's no solution, I'm going to say, well, how do you know? So your proof that it's no solution is by getting it down to this statement that you're going to tell me is true or false. Does 30 actually equal negative 4?
No.
No, it does not. So that's false. So then I would write no solution. My answer isn't 30 equals -4. That's my proof to what my answer is, which is actually no solution. Okay, so I actually need to write no solution on my work paper. We'll end with this one. We got like one more, I think, 2 more. Oh yeah, I definitely want to do this one tomorrow. And we're going to do, this is what our 1.3 activity is going to be. You have a problem like this in your homework where you have to do the surface area and volume. Yeah, we'll talk about that tomorrow. Until then, you can do all the other ones. The circles are identical. What is the area of each circle? Well, if the circles are identical, they should have equal areas. So how do I find the area of the first circle? Pi r squared. What is r? Squared. Okay. And that's equal to radius here is 2x. So pi times 2x squared. Pi's cancel out, right? That's easy enough. So when wait, why did I put this one in here? Oh, okay. Sorry. We're getting into algebra 1 right now. We'll come back to that because you guys will have to do, this is called factoring, or not factoring, it's called, factoring is one thing you can do from this. This is actually called multiplying 2 binomials. We'll get to that maybe later. How about this? If the circles are equal, their areas will be equal, but won't their radiuses be equal? Why don't we just do that? The radius of the green circle should be equal to the radius of the purple circle. Oh, that's the diameter. Thank you, Brady. You already told me that the radius is what? 2. Is this going to be no solution, infinite solutions, or will I actually get a solution? You'll get a solution. Let's subtract x from both sides. What is my solution going to be? There you go. We'll pick it up there tomorrow. Go ahead and get started on 1.3. Yes. I'll see you guys tomorrow. Have a great day.